Good afternoon, everyone. How are you all doing? This is Mike coming back at you with yet another video on Introduction to Algebra. In the previous video, we talked about multiplying and dividing rational expressions. We saw how it was very similar, at its core, the exact same thing to multiplying and dividing just basic fractions, but now we have some variables and some polynomials and whatnot being thrown into it. In this video, I want to talk about least common denominators. And just like the last section, at its core, we are doing the exact same thing as we did with something that we have already worked with quite a bit, but now we are doing stuff with variables and factors containing variables and polynomials and whatnot and that kind of stuff. We should all be familiar with the phrase least common denominator. We've said it who knows how many times. We have plenty of experience with finding the least common denominator of two fractions. But we have done this where the denominators of these fractions are just numbers. As I said, now we're going to get variables thrown into the mix. And I want to present sort of an alternate way that we can find the LCD of two fractions where the bottoms are just numbers. And the reason I want to present this alternate way is because we're going to be using this alternate way when we find the least common denominator of rational expressions. So we are used to, let's say we were given, say, 2 over 5 and let's go 4 over 7. You know, if we had to find the LCD of these two fractions, we would say, okay, so let's write out all the multiples of 5. So 5, 10, 15, 20, 25, 30, 35, 40, so on and so forth. And then we do the same thing with 7 here. We go 7, 14, 21, 28, 35, so on and so forth. And we just see, okay, what is the smallest number that is in common to each of these two lists? And it's really easy to look and see that 35 is the smallest number that appears in both of these lists. But sometimes we're working with larger numbers. And it could take a bit more time to figure out what the LCD was. So there's another way, a different way, that we can find the LCD of two fractions. And we will want to use this method when we start throwing variables in. So what you're going to do is you're given two fractions. You're going to factor each denominator into its prime factors. Basically, things that you can't break down any further. Then, once you've done that with each denominator for each fraction, you're going to list each different denominator factor the greatest number of times it appears in any of the two denominators. Then once you've done that, we're going to multiply the factors from step 2, and that will give you your LCD. So I'm going to do a couple samples here to show you what the heck did I mean by all of that. So here, 5 over 24 and 7 over 30. Let's find the LCD of these two fractions. So I'm going to take a look at the denominators, aka the 24 and the 30, and I'm going to rewrite each of these guys as a product of prime numbers, or also known as a product of numbers that cannot be broken down any further. So 24, I know, is 2 times 2 times 2 times 3. 24 is 8 times 3, and 8 is 2 times 2 times 2. And 2 and 3 are prime numbers. 30, I can rewrite as 2 times 3 times 5. These are each prime numbers. You can't break those guys down any further. So this is step one. I've factored each of these denominators into things that can't be broken down any further. Now, I'm going to look at each of these things, and I'm going to look at each prime number that shows up in either one of these, and whatever is the greater number of times that it shows up in these two, I'm going to write it that many times. So let's start with the 2's. Here we have 3 2's. Here we have 1 2. So for the purposes of finding my LCD, I'm going to have 3 2's here. Okay, let's go on to the next, the 3's. I have 1 3 here. I have 1 3 here. The larger of 1 and 1 is 1. So I'm going to have another 3 here. And now the last prime, the last new prime, 5. There's 1 5 here. There's 0 5's here. The larger of 0 and 1 is 1. So I'm going to have 1 5 there. So I had 3 2's, 1 3, and 1 5. I'm going to multiply all of these together, and that is going to give me 120. So 120 is the LCD for these two fractions. We'll do this once again with this sample here, one more to show you how this works. We're working with slightly larger numbers now. 11 over 42 and 20 over 63. So again, I'm going to take each of these denominators and I'm going to write them each as a product of prime numbers. So 42. 42 is 6 times 7. 7 is prime. 6 is not. We can break 6 down into 2 times 3. So 42 is 2 times 3 times 7. Each of these numbers is prime. We're multiplying these guys. 63 is 9 times 7. 7 is prime. 9 is not. 9 is 3 times 3. So 63 is 3 times 3 times 7. So now I've written each of these numbers as a product of numbers that cannot be broken down. Now let's look at what primes are happening in either of these numbers and write that prime the greater number of times that it's happening. So starting off with the 2's, I have 1 2 here, I have no 2 here. The greater of 1 and 0 is 1. Next, the 3's. I have 1 3 here. I have 2 3's here. So I'm going to have 2 3's in my LCD. Neither of these guys contains a 5, so we don't have to mess with 5's. 7's. 1 7 here, 1 7 here. The greater of 1 and 1 is 1. So now, I have 2 times 3 times 3 times 7. That's 21 times 6, which is 126. 126 is the LCD of 42 and 63. So I want us to look at the method that we used. We took each of these denominators, we broke it down to equal a product of things that we could not break down further. You know, we can't factor 2 anymore, or 3, or 5, or 7. So we rewrote these things as a product of numbers that we couldn't break down further. We looked at these two numbers that were in prime factored form. It's a bit of a recap of a vocab phrase that we saw earlier on in the course. And we said, okay, what's the larger number of times that prime is showing up? So we took the larger number showing up, and then we just multiplied those things. So now we're going to see how this works. We're going to use that same process to now determine the LCD of rational expressions. But now we're having variables and letters being thrown in. So we're not going to focus just on the primes. We're going to be focusing on variables and factors, things containing x's, things that cannot be broken down any further. So here, let's do some practice with some of these problems here. So we're going to find the LCD of the expressions, or some of the expressions that are given to us below. So the first one here, 8 over 2x and x minus 1 all over 10. So we want to find the LCD of these two rational expressions right here. So again, I'm going to take these two denominators and I'm going to write them each as a product of things that cannot be broken down any further. So the 2x is just 2 times x. We can't break down the 2 any further, and we can't break down the x any further. So it's just 2 times x. The 10 we can rewrite as 2 times 5. So that's good. So now we've broken each of these denominators down into things that you can't break down any further. So now let's look at what are the things showing up in either of these guys and how many times should they be included in our LCD. So looking at the 2's here, we have 1, 2 here, we have 1, 2 here. The larger of 1 and 1 is 1. So we're going to have 1, 2. Here we have 1, 5. Here we don't have any 5's. So the larger of 0 and 1 is 1. So we're going to have a 5 there. And now here we have 1x. Here we have no x's. The larger of 1 and 0 is 1. So we're going to have 1x there. And now if we multiply these things, we get 2 times 5, which is 10, times x, or 10x. And 10x is the LCD of these two rational expressions right here. Let's take a look at this guy here. 3x squared and 6x to the 4th. So the 3 is just 3. We can't break 3 down any further. And I'll move this up so that you can actually see what the heck it is I'm talking about. The 3 is just 3. That's it. X squared, so 3 times x squared. The x squared we can rewrite as x times x. So 3x squared is 3 times x times x. All right, 6 times x to the 4th. Well, 6 is 2 times 3. And then the x to the 4th is x times x times x times x. So now, if we look at these things here, let's see. Starting off with the 2's. There's 1, 2 here. There's no 2's here. So our LCD should have the larger of 1 and 0, or 1, 2. 1, 3 here, 1, 3 here. Larger of 1 and 1 is 1. Now here we have 2 x's. Here we have 4 x's. The larger of 4 and 2 is 4. So our LCD is 6 times x to the 4th power, which we see in this case was just the denominators of one of our rational expressions. And sometimes that is the case, and that's perfectly fine. All right, now let's kick it up one little notch. Let's get some other factors involved here. 4m cubed and 6m plus 12. All right, this 4m cubed here. Well, 4 is 2 times 2. Great. And then the m cubed is m times m times m. 6m plus 12 is the same thing as 6 times m plus 2, and that's going to be very, very key here. The 6 we can break down, the m plus 2 we cannot. M plus 2 is its own factor. But the 6 we can rewrite as 2 times 3. And then we're multiplying that by that m plus 2. So now finding the LCD. Here we have 2 2's. Here we have 1 2. The larger of 2 2's and 1 2 is 2 2's. Here we have a 3. Here we don't have any 3's. So the larger is 1 3. Here we have 3 m's. Here we have no m's. Don't confuse this with saying, oh, we have 1 m. No, no, no. This is its own separate factor. M plus 2 is not the same thing as just m. So here we have 3 m's. Here we have no m's. So the larger is those 3 m's. And here we have an m plus 2. Here we don't have an m plus 2. So I have to multiply by an m plus 2. And now, when I multiply these things, I get 12 m cubed times m plus 2. And this is my LCD. You could multiply this 12m cubed into each of these two terms. That would be fine too. That would still give you a correct LCD, but not something that you have to do. We'll go with this one. We'll do this one together. I'll let you try this one on your own. Here we have 5x minus 5 and x squared minus 2x plus 1. So the 5x minus 5, I can pull the common factor of 5 out of each of these terms, and that gives me 5 times x minus 1. 5 is prime, we can't break that down. X minus 1, we cannot reduce that any further. It just is x minus 1. X squared minus 2x plus 1, we can factor this. We get x minus 1 times x minus 1. And each of these guys we cannot break down any further. So now finding the LCD, let's take a look at what things are we multiplying, and we'll take the larger of the amount that's happening between these two denominators. Here we have 1 5, here we have no 5's. So it's going to be 1 5 there. Here I have one factor of x minus 1. Here I have two factors of x minus 1. So the larger number is 2. I have two factors of x minus 1. So it's going to be 5 times x minus 1 times x minus 1, or 5 times x minus 1 squared. So as I said, I will let you try this next one here on your own. Find the LCD of x squared plus 7x plus 12 and x squared minus 9. As we move on to the top of the next page here, I'll let you try this one over here on your own, and we'll get started on this one here, but then I'm going to let you complete that one on your own as well. X cubed minus 5x squared plus 6x, and x to the fourth minus x cubed minus 2x squared. In this one here, each of the terms contains a common factor of x, which we can pull out. So we're left over with x squared minus 5x plus 6. Here, each of these terms contains an x squared, which we can pull out to give me x squared minus x minus 2. And now if we factor these trinomials here, x squared minus 5x plus 6, using our basic techniques of factoring, x minus 3 and x minus 2. This guy here, x squared minus x minus 2, x minus 2, and x plus 1. So from there, I will let you figure out what the LCD is on your own for that one, and then you can try this one on your own as well. So guys, that concludes this video on finding the LCD of two rational expressions. Hopefully I was able to really help you see that this is nothing different from what we can do with just basic fractions where the bottoms are numbers. We're just doing it with some slightly different stuff. In the next video, we will move on to our next section, section 6.4, adding or subtracting rational expressions. It's going to be very similar to adding or subtracting just basic fractions. So if you have any questions or comments, see me after class, stop into my office hours, send me an email, whatever you have to do. Until the next video, take it easy, guys.